Good afternoon, everyone. Continuing with problem 27 from Chapter 3, Section 4. You were given f of x equals x times the square root of the quantity x plus 3. And we talked about how oftentimes it's beneficial to modify your original expression, give it a makeover, if you will, prior to taking the first or second derivative. In this case, we definitely would need to do that. You don't have to, but it makes life a whole lot easier. So here we have f of x equals x squared. This x becomes an x squared when you put it under the radical. You can distribute it to the quantity x plus 3, giving us the square root of x cubed plus 3x squared, or x cubed plus 3x squared to the 1/2. Putting it in this form makes it a lot easier to take the derivative of, because then it's just a simple chain rule. So, we want to take the first derivative. We use the power rule and the chain rule, and we get 1/2 times the quantity, x cubed plus 3x squared, whatever was in the inside, to the negative 1/2 times the derivative of whatever's on the inside, 3x squared plus 6x. And then it's probably beneficial to put this negative 1/2 in the denominator, and then we would have 3x squared plus 6x, still in the numerator, over 2 times the quantity, x cubed plus 3x squared to the 1/2. At this point, we might want to take, I notice an x squared, an x. This will become, we can get an x out of that, we can get an x out of that. So we can simplify this a little bit, probably make our lives easier. And again, this right here is x squared times x plus x squared times 3x. And then that becomes the square root of x squared times the square root of x plus 3x. And so we can then say that this is x times the square root of x plus 3. Yeah, not 3x. I made a mistake there. Lo siento. X plus 3. And x plus 3 there. Won't be the last time. Definitely not the first time. Okay. So then we're good. And over here, I'm going to get rid of this because we don't need it anymore. Now you'll notice we were able to factor out an x from the numerator, factor out an x from the denominator, and these x's will divide to become 1. I saw a guy do the big 1 like that. That was kind of cool. It just becomes 1. And then this expression here is quite a bit simpler, and at this point you can take your second derivative. See, we did several steps there prior to taking the second derivative, and that is a good thing to do to make your life easier. Okay, so the second derivative now of x equals the denominator 2, and you can either express it as the square root of x plus 3 or x plus 3 to the 1/2, whichever you're more comfortable with. It really doesn't matter, times the derivative of the numerator. Now, the derivative with respect to x of 3 times x plus 2 is just going to be 3 times 1, essentially, because this coefficient out here has no x term, and then we can just multiply it times the derivative of what's ever on the inside is just 1. So then that's nice. So that'll be times 3. And then minus, we're using the quotient rule now, the numerator, x plus 2, times the derivative of the denominator, and that's going to be the coefficient 2 times, let's think of this, I'm going to erase this and make it as x plus 3 to the 1/2. It's just easier to see when you're doing that power rule. So then we'll have, back here now, we'll have 2 times the coefficient 1/2 times whatever's on the inside, x plus 3 to the negative 1/2. And then it's going to be times 1, but we don't see that just because it's x here. So that's nice. And then all over the denominator, 2 times x plus 3 to the 1/2, all of that squared. Okay? And now that looks a little messy, but we can clean it up. We can definitely clean that up. So f double prime of x equals, we have a 2 and a 3, so we can go 6 times x plus 3 to the 1/2 minus, let's just leave that one there. We can mess with it later, but that 3 times x plus 2, this is kind of a singleton. It's really not going to help us because notice we have an x plus 3 here, an x plus 3 here, and an x plus 3 over here. Those will help us. This one we can just bring along for the ride. Times, we have 1 times 2 times 1/2. All of that is 1. So this cleans up nicely to become x plus 3 to the negative 1/2. Now I know in class today I was tempted to bring this negative 1/2, and I think I even suggested it. And that was my mistake. Boy, that knocked me down and was hard to get up from. I worked on it for quite a while. We need to leave that there, and I'll show you why in just a minute. Okay. And I think instead of writing this as x plus 3, let's write it as x plus 3 to the 2 over 2 power. That's unchanged. 2 over 2, same as 1. It's just in disguise. We gave it another little makeover. So now we can say f double prime of x equals 6 times x plus 3 to the 1/2 over 4 times x plus 3 to the 2/2 minus 3 times x plus 2 times x plus 3 to the negative 1/2 over 4 times x plus 3, and again to the 2/2. So now notice we have the same base, x plus 3, quantity x plus 3, raised to different powers, and we're dividing. And you remember what to do with the exponents. And we have the same base, quantity x plus 3, raised to the negative 1/2, and down here raised to the 2/2. So we can, because we're dividing, subtract those exponents. So now we have f double prime of x equals 6 times the quantity x plus 3 to the 1/2 minus 2/2 over 4 minus 3 times, bringing the x plus 2 along for the ride, x plus 3 to the negative 1/2 minus 2/2, also over 4. And we'll clean these up a little bit more. Don't panic. So now we have f prime of x equals 6 times the quantity x plus 3. 1/2 minus 2/2, that's the negative 1/2, still over 4, minus 3 times x plus 2 times the quantity x plus 3. Negative 1/2 minus 2/2 is negative 3/2. Again, all over 4. So let's get these negative exponents out of the numerator and into the denominator to make them positive exponents. F prime of x equals 6 over 4 times x plus 3 to the positive 1/2 minus 3 times the quantity x plus 2 over 4 times the quantity x plus 3 to the positive 3/2. Then we have f double prime of x, second derivative. So we have now the x plus 3 to the 1/2 over here and x plus 3 to the 3/2 over here. We really want to get common denominators anytime we're subtracting fractions. And even though these are a little messy, yes, they are fractions. So let's multiply numerator and denominator by x plus 3 to the 2/2. We did that before, so we're used to it. X plus 3 to the 2/2. See, it's just a multiplicative identity. 1, all that is 1 in disguise, times 6 over 4 times the quantity x plus 3 to the 1/2. That's just this guy here. I'm just bringing that down, multiplying it times 1, minus 3 times the quantity x plus 2 over 4 times the quantity x plus 3 raised to the 3/2 power. I have to make a little bit more room here. This was left over from today, but we're not quitters. We are not quitters around here. Okay, so now that we've done that, done our multiplication here by 1, we have f double prime of x equals 6 times x plus 3. And this is really just the first now. Over 4 times x plus 3. And this is 2/2 plus 1/2 gives us our 3/2. I'm not going to do that in detail this time. I think we can see that. Minus 3 times the quantity x plus 2 over 4 times the quantity x plus 3, also to the 3/2. So we're getting closer and closer all the time. So now, a little bit more, not a lot more, f double prime of x equals, we can distribute thusly and thusly, being really careful with that negative sign, because that's where a lot of people go wrong. So now we have 6x plus 18, because again, that's just the first power. We can distribute into that. Minus, and I'm going to put this separate, minus 3x plus 6. And that minus has to distribute over 4 times the quantity x plus 3 to the 3/2. Okay, we're almost done. Oh, I still didn't have enough room down there. Terrible. Terrible. Extend page. Drag that down a little bit farther. We'll be done. Okay, last step. We're here, gang. We made it. F double prime of x equals then 6x minus 3x plus 18. And then it's minus 6. Notice this distributes to this. Think about it like negative 1 times 6. Minus 6 over 4. Nice 4. 4 times x plus 3 to the 3 halves. And then that f double prime of x equals 6x minus 3x is just 3x. Got ahead of myself there. 3x plus 12 over 4 times x plus 3 to the 3 halves. Or you could say that this is 3 times x plus 4 over 4 times x plus 3 to the 3 halves. And granted, we don't have an actual x equals, and that's why I was saying today in class, at this point, look at the values of x that are negative, positive, or equal to 0, and you can evaluate this function. And we'll do that. Okay. So we have, I'm going to maybe bring this down. I'm going to clone it. Clone it. We're almost done. I'm at 16 minutes. I'll get you out of here under 20. And you can fast forward through some parts of it if you don't need to. So, pick a value of, and let's keep in mind this is f double prime of x. So, pick a value, let x equal, something like negative 10. Okay? When you do this, it'll go negative 10 plus 4 is negative 6. 3 times negative 6 is negative 18. So it's still negative in the numerator. And when you go negative 10 plus 3, you'll get negative 7. When you take negative 7 to the 3 halves power, it's still negative. When you go 4 times that number, it's still negative. And so that equals positive. And then obviously, if you let x equal positive numbers, then this will be positive over positive. Let x equal, positive 10, just to illustrate that, but it really can be anything. You'll get positive over positive equals positive. Okay, now this is very important. The only time that f double prime of x equals 0 well, really it doesn't, because it'll be undefined. Let's just say the only exception is when x equals negative 3, which makes the function undefined. So no inflection point when it's undefined, obviously. So all values of x in the domain produce a positive result, is what this is saying. Anything at all that you can put in this domain will produce a positive result. What does that mean for the function? Okay. So all values of x produce a positive result. They'll say f double prime of x is greater than 0 for all x. Therefore, just a second, I gotta blow my nose. Okay, I took the opportunity to set up the calculator on that break. So we said f double prime of x is greater than 0 for all values of x in the domain, except -3, which is undefined. And then we can say, therefore, the original function is concave up. What would I say? Concave up. Yeah, I'll just say concave up only. I was trying to think of a really good way to phrase that. Concave up only and has no inflection points. Okay? Now that we've done that without our calculator, let's jump into that and take a peek at it. This is cool. Okay, so I put it in as originally defined, x times the quantity, or x times the square root of x plus 3. Set my window. When we graph that puppy, there it is. There's the -3, undefined. And for all other values of x, that is concave up, and there are no inflection points. And we know that because the second derivative is positive, meaning greater than 0, for all values of x. And that is pretty cool. Finally got it. Boy, that one was tricky, and I'm glad that Kylie asked that question, and hopefully this is all helpful to you, and you can do great on tomorrow's quiz. And as promised, I will not put anything that takes this long on tomorrow's quiz, but I will put problems on tomorrow's quiz that have this same content covered. Just don't take that long. All right, so we made it in 22 minutes. Thank you for watching. I hope this is helpful, and have a good night.